DPRJones, I cannot answer your question right now. Not in the best terms. I have a basic understanding, but I'm working on it. But I'm hoping to be able to get an answer to you very soon, because I am currently reading Relativity itself. I should have a better understanding, seeing as I actually got this book out the 28th of July 2003. I owe the library a lot of money and a book. But cheers for a good question, and making my brain work even harder is good. But until I can answer it in my own words, hopefully this can help, courtesy of, I believe it was the Discovery Channel.
Einstein's big idea was that the amazing speed of light holds the key to everything, from the untold power of the atom to the possibility of time travel. To follow in the footsteps of his genius, imagine the great scientist in a rocket ship, floating in deep space. The ship has powerful headlights, and when Albert switches them on, the light races away from him at, of course, the speed of light, 670 million miles an hour. Now imagine that Albert has a twin brother, Bertrand, who also has a spaceship. Let's say Bertrand flies away from Albert at half the speed of light. When Albert turns on his headlights, how fast would they seem to be going when they overtake Bertrand? You'd think he would see them pass by relatively slowly, like a faster car passing you on the highway. But that's not the way light works. Instead, Bertrand would see Albert's high beams pass him at the full speed of light. Bertrand's own speed makes absolutely no difference.
This prediction of Einstein that the speed of light is the same for everyone is one of the strangest in physics. But it's true. It's been shown by hundreds of experiments. The speed of light is going to be the same, no matter how fast you're moving towards it or away from it.
Even if Bertrand turns around and travels head-on towards Albert, he would still see Albert's headlights pass him at the same speed. So what's going on? Welcome to the realm of time travel. If both brothers see light moving at the same speed, then something else must be changing. That something is time.
Something has to give, and the things that have to give are space and time. It turns out that if an object is moving fast enough through space, it can alter its passage through time.
If Bertrand's ship had some suitable equipment, we could see this mysterious effect for ourselves. This device is a light clock, two mirrors that face each other with a particle of light, or photon, bouncing between them. Each bounce is one tick of the clock, and in the right hands, such a clock shows directly how speed changes time.
These ticks would normally occur millions of times per second, but we have slowed it down to show how this clock works and how the motion of it will affect the rate of ticking. You'll notice that the clock is ticking more slowly as I move it. Why is that? Well, the photon is making a zigzag path to reach one mirror and then the other. That's a longer path that the photon has to take, and that means that it takes more time to make that path. So the clock is slowing down.
This is where physics and science fiction collide. Time for the moving clock runs slow, although if you travel with it, like Bertrand, you're not aware of the change. That's because everything happening on board, including your heartbeat and your brain waves, would slow down by the same amount. The faster Bertrand travels, the further the photon has to go between ticks, and the slower time passes for him. So what might be an hour for Bertrand could be 100 years for the rest of us. In effect, he would be traveling 100 years into the future.